Sharks are some of the most captivating animals on Earth. They've been cruising through our oceans for hundreds of millions of years, long before dinosaurs stomped around on land and long before humans even existed to obsessively make documentaries about them. Sleek, efficient, and often misunderstood, these incredible animals play critical roles in maintaining the balance of marine food webs. Without sharks, our oceans would function very differently, and probably not in a good way among the long lineage of sharky excellence. However, there is one creature that consistently reigns supreme in the public imagination. One shark that has achieved almost mythic status. One apex predator so legendary that it spawned blockbuster films, best-selling novels, and more viral. You won't believe how big it was, infographics than anyone could reasonably count. That shark, of course, is Megalodon. Cue dramatic music, maybe a few whale carcasses for scale. Megalodon, technically Otodus megalodon if you want to impress people at dinner parties, is among the most famous prehistoric animals ever. Even people who couldn't name 5 modern shark species know the Meg. It's basically the celebrity shark of the fossil record. But for all the hype, there's a surprising twist. We actually don't know exactly what Megalodon looked like. Not 100% for sure. Not in the way we know what a T-Rex or a woolly mammoth looked like. And that's where things get interesting. Why we don't have a clear picture. Here's the problem. Sharks are made of cartilage, not bone. And cartilage doesn't fossilize well. It's too soft, too flexible, and too easy for time, pressure, and microbes to erase. Bones, like those of dinosaurs or mammals, preserve beautifully by comparison. Cartilage, not so much. So while countless prehistoric animals left behind gorgeous skeletons we can study and mount in museums, most sharks did not. For Megalodon, that means that almost everything except its teeth and, occasionally, some vertebrae have vanished into deep-time oblivion. Megalodon teeth, by contrast, are absolutely everywhere. They are thick, triangular, serrated, geologically durable, and alarmingly large. A single meg tooth can be bigger than a human hand. These teeth formed the backbone, pun intended, of Megalodon science for more than a century. But teeth alone don't tell you everything. They can tell you about diet, they can tell you about size in a very rough sense, and they can definitely tell you that you do not want to be a whale in the Miocene. But they can't tell you exactly what the animal's head shape, fin proportions, or overall body plan was. So for a very long time, scientists and artists filled in the missing details with the most obvious living candidate. The great white shark, the great white assumption. For decades, Megalodon was depicted as basically a great white shark scaled up to kaiju proportions. This idea wasn't totally random. The teeth of modern great whites and the teeth of Megalodon look superficially similar. Both are serrated, triangular, and built for slicing into the soft tissues of marine mammals. Plus, great whites are apex predators today, so it seemed reasonable to assume Megalodon filled a similar niche in the past. So for much of the 20th century, textbooks, museum murals, and ocean documentaries featured Megalodon as an enlarged white shark. Same proportions, same body depth, same fin layout, just 3 to 4 times bigger. But as it turns out, that assumption was built on shaky ground. ScienceDocumentary researchers looked more closely at shark evolution, tooth morphology, and lineage relationships. They realized something important. Despite the superficial similarities, great whites are not Megalodon's closest living relatives. Not even particularly close. Megalodon belongs to Otodontidae, a now extinct family within the broader lamniform shark order. Great whites, on the other hand, belong to Lamnidae, along with species like makos and salmon sharks. Both groups are lamniforms, but not sister groups, more like distant cousins than direct ancestors. This realization chipped away at the great white as template model. If Megalodon wasn't a giant great white, then what was it? How exactly was its body proportioned? Did it have the same fin shapes? The same head-to-body ratios? The same muscular architecture for cruising and ambush? For a while, the answers remained elusive. Then, around 2020, things took a dramatic turn, and Megalodon reconstructions entered what can only be described as their scientific plot twist era. The robust Megalodon ERA, 2020 to 2022, the first major modern revision came in 2020, when a team of researchers decided to rethink Megalodon's body plan using a fresh comparative approach. Instead of only using great whites as their anatomical playlist, they sampled multiple living lamniform sharks that shared high metabolic rates, fast cruising behavior, and macro-predatory lifestyles. Their lineup included shortfin macalongfin macasalmon sharkporby gleaned. Yes, the great white. These species aren't identical, but they're ecological analogs. They have high-performance bodies, powerful swimming musculature, and diets involving other vertebrates. In the absence of Megalodon soft tissues, this was a more diverse and reasonable proxy. Using precise anatomical landmarks, things like distances between fin bases, proportions of head depth to trunk width, and tail fin angles, the researchers built a 2D proportional reconstruction of Megalodon. The result? The first detailed scientific image of Megalodon that wasn't just great white but big. The model depicted an animal that was very large, no surprise there, wide-bodied, muscular, robust in the head and trunk with a tall, narrow dorsal fin and a strong heterocircle tail angled slightly upward. One interesting detail was the head. Based on the scaling trends they observed, Megalodon would have had a significantly bulkier skull and jaw musculature than living great whites. The snout likely curved more gradually into the body to accommodate larger jaw muscles, rather than tapering off sharply the way a white shark's does. If your main job is to punch holes into whales, you want the jaw equivalent of a hydraulic press. In short, the 2020 work painted Megalodon as a supersized lamniform athlete, capable of powerful bursts of speed and endurance swimming across huge distances. And this reconstruction was just the beginning of the transoceanic superpredator, 2022. In 2022, many of the same researchers leveled up again, this time using a 3D digital reconstruction built from an extraordinarily complete fossil. Backbone. This key fossil, known informally as the Belgian vertebral series, contains 141 vertebrae that all probably belong to the same animal. That level of completeness is unheard of for a Megalodon. Most shark vertebrae never fossilize at all. But in this case, a combination of environmental burial conditions and the unusually dense calcification of Megalodon vertebrae produced a jackpot of anatomical data. The team digitally scanned each vertebra and then scaled up a modern great white shark skull to serve as a placeholder cranium. They wrapped the digital skeleton with soft tissues modeled from a great white CT scan, and then finally adjusted the proportions based on their earlier 2D reconstruction. Was it still biased toward great whites? Yes. But it was the most comprehensive attempt to date, and at the time, it felt like the best method available. The result was dramatic. The completed 3D Megalodon reconstruction measured 15.9 meters long, roughly 52 feet, and weighed an estimated 61,560 kilograms, almost 68 US tons. For reference, that's more than the mass of a fully loaded semi-truck. It also far exceeded previous weight estimates for a shark of that length. With that much muscle to move, Megalodon had serious metabolic demands. The team estimated it would have needed nearly 100,000 kilocalories per day, about 20 times the caloric needs of an adult great white. But here's the thing, whales are basically giant tubes of portable, floating energy. If you have access to blubber, liver tissue, and rich muscle, you don't need 3 square meals a day. Eat one whale, and you're good for a while. To illustrate, 21 kg of whale blubber, 17 kg of shark liver, 32 kg of shark muscle could, in theory, satisfy the daily energy requirements of a Megalodon of this modeled size. Of course, no one is suggesting Megalodon packed its meals into neatly weighed portions. Nature is not a meal prep service, but the math makes the point. Speed, range, and hunting IMPLICATIONS. Perhaps the most headline-grabbing claim of the 2022 study was that Megalodon would have been a fast, ocean-crossing cruiser, with an estimated sustained cruising speed of about 5 kilometers per hour, 3.1 miles per hour. Now that doesn't sound fast until you realize that that is an average cruising speed, not a sprint, and it is significantly faster than the cruising speeds measured for living sharks. In other words, if true, Megalodon was not just a giant whale-munching machine, it was a mobile whale-munching machine. Great whites today routinely travel thousands of kilometers across the open ocean. If Megalodon could cruise even faster, as the 2022 model suggested, then it could have patrolled entire ocean basins in search of prey. Some journalists at the time dubbed it the transoceanic superpredator, which sounds like a sci-fi movie title but was surprisingly accurate to the study's modeling assumptions. Under this reconstruction, Megalodon becomes something like the marine equivalent of a wide-ranging top predator, constantly moving, burning energy, and intercepting migrating marine mammals. For a brief moment in the early 2020s, this was the gold standard popular image, a beefy, hydrodynamic tank of a shark equally suited for cruising and ambush. But science doesn't stand still, and paleontology doubly so, because just a few years later, a competing interpretation emerged that would challenge almost every aspect of this bulky Megalodon model. The scientific pendulum was about to swing hard. Where this leaves USO after decades of imagining Megalodon as a gigantic great white shark on performance-enhancing supplements, the most recent wave of research paints a very different picture. One of a long, efficient, lemon shark-shaped titan, capable of cruising vast distances without burning through absurd amounts of energy, ambushing whales with bursts of speed rather than constant fast cruising, and reaching lengths that potentially rival small baleen whales. Now, it's important to emphasize that this new model isn't claimed as the final answer. It's a working hypothesis, and the researchers behind it are perfectly clear about that. They're operating with incomplete evidence, as everyone in shark paleontology must, and they chose median proportions precisely to avoid overcommitting to extreme scenarios. But if nothing else, the last 5 years of Megalodon research have taught us this: there is no single default Megalodon body shape anymore. The once dominant great white analog has been dismantled, the bulky super predator tanker model has been challenged, and the long, streamlined version now sits as the most evidence-consistent configuration at present. And honestly, it's exciting, because if Megalodon really was more lemon-like, it means we may have been underestimating its maximum length all this time. Instead of topping out around 15 to 20 meters, some individuals may have pushed into the mid-20s. That doesn't just make Megalodon big, it makes it one of the longest macropredators the planet has ever produced. Not bad for an animal we mostly know from teeth. Now, no matter what Megalodon actually looked like, one thing is for sure: it was an apex predator on a scale the oceans will likely never see again. It fed on whales, dolphins, seals, and pretty much any marine mammal that had the misfortune of existing alongside it. It shaped ecosystems, influenced food webs, and ultimately disappeared for reasons we're still piecing together, possibly climate change, possibly prey loss, possibly both. As more fossils are discovered and new technologies emerge, we'll keep refining our understanding. Maybe one day we'll get lucky and uncover a full skeleton. Until then, the story of Megalodon remains one of science, imagination, and the thrill of discovery. I hope you enjoyed this Shark Week 2025 special. I know we usually produce a whole week's worth of sharky goodness, but it's been a hectic year, so this documentary deep dive had to carry the banner. If you want more Jurassic, Cretaceous, Miocene, and Pleistocene chaos, be sure to check out our previous Shark Week videos. There's plenty to binge. Don't forget to like the video, subscribe if you haven't already, and hit that bell icon so you don't miss our next upload. And if you want your weekly dose of paleontology news, follow our science channel, 7 Days of Science, where we break down all the newest fossil finds and research developments from around the world. And hey, if you need more shark content right now, go support my mom's channel, One World, because she just released her own Shark Week feature. Thanks for watching, and we'll see you next time.